Hey students, this is lesson 10.5, graphing square root functions. You're going to learn how to graph square root functions and how to translate graphs of square root functions. Go ahead and it's important that you understand what a function is and how to find the domain and range. That's going to be an important part of what we're doing here. So do this review carefully and you can check back with your answers. All right, key concept here, a square root function is a function that has an independent variable in the radicand. Remember, the independent variable is usually designated by x for us. The parent square root function is y equals the square root of x. For real numbers, the value of the radicand cannot be negative. And that's, remember, you can't take the square root of a negative number like that. That's an imaginary number. There's no number multiplied by itself, no real number multiplied by itself that equals a negative number. So, true or false? The first question would be false. We need a square root in there. The second one is true. The domain of y equals the square root of x minus 3 includes the value 2. No, it doesn't. If we put in 2 for x, we get a negative, and we can't get the square root of negative. That's actually equal to I. So, all right, first problem here, finding the domain. So let's just write this down. In general, when we have a square root function, the radicand x has to be greater than or equal to 0. So to find the domain, we just need to say that 2x plus 1 has to be greater than or equal to 0. And then we can just solve that. Subtract 1, we get 2x greater than or equal to negative 1, divide by 2, and we get x is greater than or equal to negative 1/2. So what we're saying here is this function will only have outputs for inputs that are greater than or equal to negative 1. And just as a quick reminder, I want to put that in interval notation. That would look like this. If I want to put that in set builder notation, that would look like this. All right, I'll let you try that. You can check back with your answers. All right, we're going to try and graph this function. I need to fix something here. I think it's supposed to be this, where the radicand is negative 1.5 h. So this gives the distance in miles to the horizon when h is the height of the viewer's eyes above ground in feet. When will the distance a viewer can be seen be greater than 10 miles? Okay, we're going to make a table of values to help us with this one. And I'm going to take my independent variable is h here, the height, and my dependent variable is the distance. And now I'm going to have to think about what values I want to use, and of course I want to be able to answer the question, when will it be greater than 10 miles? Well, think about this. The square root of what number equals 10, and that's 100. So to get 100, h will have to be some number between 50 and 100. So I'm going to use inputs 0, 10, 20, 30, 40, 50, 60, 70, 80, and so on. I think that should get us to high enough number where we can see that. And then my outputs would be, if I take 1.5 times 0, I get 0. Square root of 0 is 0. If I put 10 in there, I get 1.5 times 10 is 15. Square root of 15 is a little less than 4. It's about 3.9. Square root of 20 times 1.5, 20 times 1.5 is 30. The square root of 30 is about 5.5. if I put 30 in here and do the square root of 1.5 times 30, that's the square root of 45, which is about 6.7, and so on. I'm just going to write these values down, and then we'll graph them. 8.7, 9.5, 10.2, 11.6. And then I'm going to choose my scale. Of course, it's going to be 10 down here. And then on the y-axis, we can just maybe go up by 1. That should be good enough there. And then at 0, I'm 0. At 1, I'm 3.9. Maybe that's about there. Whoops, that's right. 3.9. About there. Then 5.5. That's there. 6.7. 7.7. 8.7. 9.5. And then we're up above 10, about 10.2. If I want to keep going, 11.6 maybe is about there. But we can see what's happening here. We got a line that's slowly curving like this. And if we're just going to make an estimate here, when we want to know when the distance can be greater than 10 miles. And our distance is, right here is 10. So we want to go over to where that hits the line. We're just going to make an estimate and say that a little bit more than 65, and then it gets above 10. So for heights greater than approximately 65 is our answer. All right, I'll let you try that. All right, we're going to translate graphs, square root function graphs, and one thing we have to remember is that when you add a value to a function, it makes the graph move up that many units. When you subtract the value, it makes it move down that many units. So we're going to use that idea here. First, we're going to graph y equals the absolute value of x. To do that, I just need a couple points, and I'm going to choose some really convenient points here. I'm going to use perfect squares for my inputs. And so the square root of 0 is, now remember we're doing the square root of x, not this one. Hey. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, 3, 4. And I'm just going to plot those on there and then try to approximate the curve. So 0, 0. 1, 1, 4, 2, 9, 3. And so the graph is going to look about like that. Now remember, when you add 4 to a function like this, really we're just going to move it up 4 units. So every point I put on the graph, I can just count up 4 units from there. So 1, 2, 3, 4. That's going to be the output when the input is 0. That one being 4 higher. That one being 4 higher, and that one being 4 higher. And so there is our translation of the graph y equals square root of x to make the graph y equals the square root of x plus 4. I'll let you try it. I'm just going to change a couple things here. Oh, no. You can go ahead and do this. Check back with your answer. Okay, another way we can translate is left and right, and we do that when we are adding to the independent variable or subtracting from the independent variable. So the difference is before a translation up or down, we would have the added part outside of the square root. Now we have it inside the square root. So what we're doing is adding 4 first and then taking the square root of that. And that causes it to either go left or right. If you're subtracting, it goes right that many units. If you're adding, it goes left that many units. So this equation right here is going to make the parent function y equals square root of x move to the right 3 units. So I'm just going to locate some points here, 1, 1, 4, 2, 9, 3, and then I'm going to move each of those to the right 3 units. So that would go there, that one would go there, that one would go there, and that one would go about there, and then draw my new function in. All right, I'll let you try that. I'm going to change things here just because you just did this one. Let's make this plus just to make it a little bit different. So plus 3 there, plus 3 there. And you can go ahead and try that. And if you did it right, it should look like that. Okay, lesson check. Go ahead and try your answers first, and you can check back for the correct answers. There you go. That should do it for today. I'll see you tomorrow. Or Monday in this case.